Hello, everyone. Welcome to the Polkadot Hackathon as part of the Encode Club Polkadot Club. And today we have an intro to Substrate that's going to be led by Hang Yin from Phala, who's the co-founder of Phala and has already done a fantastic session on this as part of the Polkadot Education series. And I'll put a link to that chat that we did over the last 2 months. I'll put a link to that in the chat. And yeah, this should be an intro to Substrate and a bit more information about Phala and their challenges in the hackathon. But yeah, any questions, feel free to put them in the chat and we'll try and get to those at the end. And yes, this is being recorded. So if there's anything you want to go back and review, that should be published on our YouTube and Medium tomorrow. But yeah, over to you, Hang.
Okay. Thank you very much, George. Yeah, I'm already being introduced. So let's get started quickly. Let me present. All right. So, I think I can hide this. Okay, let me hide my dog. It's a bit annoying. Okay.
Just make it small.
Yeah, sounds better now. Let me check. Where is my? Okay. All right. Okay, so I'm very happy to be here to introduce you how to use Substrate and how to build on Substrate. And I think today the talk will be targeting some people. At least you should know a little bit about the blockchain, maybe Bitcoin or smart contract. But if you don't have the actual development experience, no worry, it will be very simple. And I won't go too deep in this talk. Yeah, so I'm Hang from Phala Network. I'm the co-founder and the lead developer. Yeah, we're going to talk about Substrate. So today we're going to have 3 sections. The first is what is Substrate, and we're going to talk about why we're going to build on Substrate rather than maybe just a Ethereum smart contract. The second section, we're going to introduce the very basic concepts in Substrate development. And the third, it won't be very lengthy. It's just a very, very simple example to start building on Substrate. Yeah, so that's the 3 parts. And before that, I would also like to introduce our project a little bit. So what is Phala? We call ourselves the Web3 cloud. And it's it's a bit different from the other blockchains because we don't focus on like DeFi or like oracles, but we focus on cloud computing. And how does it work? So just like Uber or Airbnb or Didi, on our platform, we can allow anyone, as long as you have the capable machines, you can join our network and contribute your computer as the to contribute your computation resources. And our blockchain is like a Kubernetes to organize everything, to schedule the task. So in this way, we can build something very similar to a traditional cloud, but we don't own a single server. The server are all come from the contributors. Yeah. And now we are already running as the first parchain on Kusama, and of course in the future we are going to try to become a parchain on Polkadot. Yeah, and I introduced this because this is important in our next topic. That is what is Substrate. And before we talk about Substrate, and I believe most of the people already heard about like Ethereum and Bitcoin and why we are going to build a blockchain. If we build some decentralized application, I think the easiest way is just to write a smart contract. And what is a smart contract? It's just a little piece of code on the blockchain. And it's very similar to a very common words called serverless, because you write the code, deploy it on like Ethereum or other network, and then you're done, right? You don't need to maintain the server to run that, like if you deploy on the cloud, right? And another good thing about the smart contract is it's really easy to write, especially if you write in Solidity. It's very similar to JavaScript, and it's a well-known, easy to learn language. But it also has some costs. So the first, and I think is the most common feeling about smart contract, especially on Ethereum, is that it's a bit slow. On Ethereum, the average TPS is around 15. So it means that no matter how many smart contracts are deployed on Ethereum, they share the same blockchain, and there is a fixed TPS. So it will be a little bit slow, and it's also expensive. If you if you have ever tried to interact with a smart contract, especially on Ethereum, and you probably you will find the gas fee on Ethereum is really high, and this is just a screenshot I took from a website called gasnow.org. You can also check it out. Now I think it's better, but generally speaking, if we run anything a little bit complex on Ethereum, it's very easy to cost you probably even $100 per transaction. So yeah, it's really a very annoying aspect of deploying the smart contract. But why is that slow and expensive? That's because everything share the same blockchain. So the more applications on the blockchain, the more expensive it will be on the blockchain. Yeah. And there are also some more complex application that's really hard to build on a smart contract. For example, like Filecoin and Arwave, they are storage focusing blockchains. They can allow you to store large amount of the file and in a trustless way. But how can we build such thing on Ethereum? It's really hard because they have some very complex mechanism, or they need a large amount of the computation happen on the blockchain. So I think in one word, on a smart contract have really limited resources. So it's very hard to build something complex. And of course, beyond like Filecoin and Arwave, Polkadot is a network of blockchain. So it basically connects different blockchains together. And at Phala network, we build a network of the computers. So if you don't think running a smart contract is enough to fulfill your requirements, then you're going to build a blockchain. And of course, you will get much less limits. But if you build a blockchain from scratch, it will be a very hard thing. For example, every blockchain will have a P2P network. So you need to handle all the network related stuff. And of course you need a database to save all the either is like the balances or some token amount or some other data on the blockchain. You need a database. And you also need consensus because you want the entire network to agree on some data in the database. And if you need a smart contract, you need sandbox, right? And the smart contract engine, and you also need to build the front end like staking, the staking related logic, multi-signature related logic, and that's really common on a typical blockchain. And if you build them together, it will be a huge amount of the effort you need to spend. So so that's why we are now talking about Substrate. Yeah, so Substrate is just a framework to help you to reduce the time. It is a framework and has all the ready to use modules, and then you can just like playing a building blocks, you can put them together and you only need to focus on your own business logic. So yeah, the next session, we're going to talk about the basics in Substrate. So let's take a look. What is Substrate? So this is a very high level diagram of the different parts in Substrate. So within a client, we have like P2P networking module. We have the RPC module, so user can interact with that. And it has the built-in consensus engine. It also has maybe like telemetry to collect some usage data for you. And among all of them, the most important one is in the middle of this diagram. That is the storage and the runtime. So storage sometimes is also called the database, store all the data. And the runtime is the core of the blockchain. It defines how your blockchain behave in when the blockchain is when the block is progressing, right? And if you find it out, the runtime on Substrate is built in WASM, and WASM is WebAssembly. It's a very dynamic. Well, I shouldn't say dynamic. WASM is just a virtual machine, but it's very powerful, and it's a standard. So almost all the typical languages can be built into WASM, and I think the most interesting part is that because it's running the WASM within the virtual machine, it means that the runtime is upgradable. And later we're going to talk more about that. But now, if we take a closer look at what are inside the runtime, and this is the answer. So there are roughly two parts. One is the runtime itself. Runtime is just you can say is a compiled code, and it is the WASM blob itself. It can be into the Substrate client, so it can run your own business logic. But the runtime include both the runtime definition itself and also the palettes. So the palettes are the highly abstract modules in Substrate. And if you are going to implement a new feature, and then you build a new palette and you put it inside your runtime, there are also a lot of pre-built palettes, and they are called frame. And if you check the Substrate code base, you can see there's a directory called frame, and there are a lot of built-in palettes. For example, like assets, and assets manage the balance of your token. There are like treasury and democracy to deal with the on-chain governance related stuff, and like staking contracts. They are all palettes. So you only need to pick up the palettes you want to use and plug them together as a runtime, and now you get a production ready blockchain. So that's very, very simple. All right, so that's the basic concept. So if we want to build on Substrate, what do we need to learn? So I think the first thing is that you need to be familiar with Rust. Rust is a language and is statically compiled. And well, Rust itself, compared with the other languages, maybe there is a little bit cliff in the learning curve. So maybe at the first place you think you may think it's a little bit hard, but actually if you just want to build on Substrate and you only need to know a little part of Rust. And even though it's just a little part, it's powerful enough, and it can also bring you some additional benefits. For example, Rust is a memory-safe language. So if you are familiar with C++, actually Rust is pretty similar to that, but it's easier and it's memory safe by default because it can ask the compiler to do very extensive check of your code. So if your code can leak some memory, and it will find it in the compile time. And also Rust is a very high performance system level language. So it was invited to build the browser and even the like operating system. But now we find this because of the safety and high performance is really good to build a blockchain, because we need the blockchain to be safe and we need high performance. And as long as you have some very basic understanding of Rust, you can start building. And we can start from the Substrate node template. You can find it out under GitHub substrate-developer-hub. And there is the template. And you just clone the repo locally, and then you can run it. And the template is already a very basic blockchain, and then you can build your own business logic into the blockchain, and that is to create your own palette. And finally, you run the blockchain and you can connect the front end. And Polkadot or Substrate offer you a really nice front end called Polkadot.js user interface. You can connect that to your own blockchain, and then you can interact with that. It's very user friendly. Yeah, so so that is the very basic steps to build on Substrate. And who are using Substrate? And I think the most famous ones are Polkadot and Kusama. Actually, they share the same code base. And if we check it out, you can already open polkadot.js.org, right? And you can connect that to Polkadot or Kusama. So let's just connect to Polkadot, for example. I think I can make it larger, right? So this is a running blockchain. And under this tab, you can see this is the block explorer. You can see the recent blocks. And this is the events, what happening on the blockchain. And if we click into a block, you can see the transactions inside the block. And this is the system level transaction. And if we scroll a little bit, this is like transfer, right? And even you start a really simple Substrate template, you also have some basic features shared with Polkadot. Like you can see your accounts, and you can like use the developer tab to send arbitrary transactions, or you can also make RPC call to your node. And that's all managed automatically by the front end and the Substrate node. So yeah, just some very direct feeling about Substrate. Yeah. So and what about the other things we can build on Substrate? So let me take ourselves as an example. So like Ethereum, as you know, is a single blockchain. Before it entered the 2.0 era, is still without sharding. No matter how many nodes you have on the network, it's just a single blockchain. So it doesn't scale when the network scale, right? And on Polkadot, it has probably 100 parachance. And theoretically, each parachain is a standalone blockchain, so it can have at least 100 times throughput compared with Ethereum. And on our blockchain, because we built a network with a large amount of the nodes, they can all connect to our blockchains, and each node can run different things. So we say we can scale linearly, and that's what we call linearly scalable network. And we use Substrate to organize all these so-called secure enclave workers together. So that's how we use Substrate to build our own network. All right, so that's all the introduction part. And in the third section, let's just start building. In this talk, I think we can build a really simple blockchain. And the use case I found is a simple forum. So if we build a forum and we can send posts to a forum, right? And within a post, we have title, we have the author, and we also have the content, right? And we're just going to build a simple blockchain that allow anyone to submit forum posts. And as I mentioned before, on Substrate, the blockchain can be upgraded. So I'm going to show you how we can build a very simple, build from a very simple Substrate template and upgrade it to a forum. All right, so the first is to, of course, install Rust and all the dependencies. And you can do that with Rust app. It's a simple script, and you can search that on Google. And because of the time, the limited time, we're not going to cover that. And then we can clone the Substrate node template locally. And then we compile that, and we can get a very simple, ready to hack blockchain. So let's do that. Here, to save some time, I have already cloned the Substrate code locally, and now and I can, let me make it larger. And now, as you can see, we have the exact empty Substrate template here. So we're going to build that. So we run cargo build release. And the first build will take some time. And if like you build from scratch, it may take, it depends on your computer. It may take like from 5 minutes to 15 minutes. But now I have already compiled the first time. So it's just the incremental compilation. It will take less time. So having a powerful computer will definitely help. And while it's building, I can also introduce a little bit about my habits. So I usually use VS Code, and I have a Linux box, and I can use VS Code remote to connect to the Linux box. And this is the template. Is exactly the same as the one we can download from the official repo. And in this repo, as you can see, there are a few directories, and there are docs, nodes, and node itself define the binary to run the blockchain client. I think in this tutorial, we're not going to touch anything within node. And the important things are, there are two important things. One is palette, because it defines our business logic. And another is runtime. It defines how these palettes can connect together to build a blockchain. And now it's already built. Let me check. It takes some time. Yeah, really need a powerful computer. Yeah, and a simple trick, when we start a blockchain and the default RPC API port run on 9944. So we can use VS Code to forward the port from the remote server to the local port, so that we can use the front end to access the running blockchain directly. But if you run it directly on your local computer, then you don't need any port forwarding setup. Yeah, so we have 9944. All right, it has already it's already finished. Then let's start the blockchain. So to start the blockchain, the next page, the binary, the compiled, the built binary is under target /release/node template, and that's the single binary built from our Rust code. And we're going to add two parameters. One is dev. It means we're going to start the blockchain in development mode. It can simplify a lot of things. For example, it is just a single process running locally, and it will give you some special permission so you can access all the entire blockchain without having to configuring like the on-chain governance related stuff. You have the pseudo permission. And we're also going to add another parameter called temp. So it means this is a temporary blockchain instance, and after you close that, it will clean all the code base. Yeah, it will be very handy. Let's work on that. So target release node template and div temp. All right, it's running. And as you can see, now the it's showing, it's listening for new connections on 9944. This is the RPC node. And if you check the log, it's producing block. This is the first, the second, and the third. And on Substrate, the default block time is 6 seconds. So every 6 seconds, you get a new block. And let's connect the front end to the blockchain. So the default port is 9944. So we choose local node and we switch to that. Yeah, so this is our first blockchain. It's a very, very simple blockchain with some basic stuff. You can, if you check the Explorer, you can find out it's actually producing the blocks, right? And it shows, you know, the target block time 6 seconds, and every 6 seconds you got a new block, and there are accounts. You can see these are all the accounts. Some accounts are come from our the extension, just like Meta Mask, and some accounts like Alice, Bob, Charlie, they are all the predefined development accounts. It's just for convenient. And yeah, we can try some very basic things. For example, now we already have some balances in a few accounts. We can send a transaction. So like 1, 2, 3, 4, we can send some amount of the token to another account, right? So make transfer, submit. After 6 seconds, we will see the balance. Yeah, here is already there. So yeah, this is a very, very basic blockchain. All right, so now we already have a very basic blockchain, and we're going to hack on this blockchain template. And actually, the forum post is just the first part of our a full workshop. The full workshop, you can find the instruction in here, and I'm going to share this link in the chat later. Maybe now. And let me check where to share the. I don't know where to. Oh, chat. All right. Let me just put it in the chat. Oh, I see there are already some questions in the chat. I think probably I can check a little bit before I moving forward. So share the presentation. Yes, I can share the presentation. I can just paste the link here. Yeah, and the full instruction is here. And as you can see, the title is Substrate Runtime Algorithm Storage Migration and Rehearsal. So it is a more advanced topic, but today we're just going to cover the first part, which is really easy. Decide the right block time for my chain, and I think the default block time is really nice, but don't try to make it too small. Like in my view, any block time less than 6 seconds will having some problem, because there are consensus related issue, and we need time to broadcast the transactions to the network. All right, so let's continue. Yeah, so let's check the code. Before we move forward, today we're going to make some change in the palette and make it to support posting the forum, allow user to post some forum posts, right? So let's just roughly go through what is a palette. And I don't think understanding of the palette of Rust is really important, because I think you only need to know a little part and you can start working. So palette, of course, there are a lot of files, but the most important one is lib.rs. And within the palette module, there are a few important things. One is the storage. So you can define a storage like this. Basically, you give it a name and you define it as a storage value. And of course, a value is a single value. And we are also going to, if we want to store a list of the forum posts, then we're going to use storage map. That is a map, it maps from an ID to some real content. Yeah, and we can issue some events just like Solidity and arrows, of course. And now in this section, it defines the cause of this palette. It means that you can send a transaction to invoke these functions. And now there's only do something. So it basically accepts just a single unsigned int 32. Yeah, and it store the value into the storage and make an event. And there's also another function trying to create an arrow on the blockchain, just to showcase. And in this tutorial, we're going to build a forum post. So just to save some time, let's just check out the my prepared branch. Let me figure that out. So yeah, so it's not cheating, but I will go through everything. But before that, let's build the new blockchain. Cargo build, release, because building the new blockchain takes some time. Yeah, let's see what have been changed. The first thing is that now we have a function called post. It accepts two parameters. One is title, another is content. And maybe you think it's a little bit weird. We just accept some vector U8 means it's some bytes. Why not accepting string? This is a little restriction on substrate end, but you can always use bytes to represent some string. Yeah, and next, we're going to store the post on the blockchain, right? So we need to define the storage. The storage is defined here. We defined two storages. One is just a value tracking the ID of the next post. So it starts from 0, and whenever we add a new post, we increment it by 1. So this is next post. Another storage item is posts. It's a map from the ID of the post to the post itself. And as you can see, the storage map take 4 parameters, but we only need to focus on the the last two. This U32 is the type of the ID, and this is the type of the value, which is the post. And where do we define the post? It defines here. So we create a structure called post, and you can safely ignore the generic parameters here. You can just ignore that and later about how generic works on Rust. But basically, we define a structure called post. We have title, we have content, and the author, right? So you can easily imagine what we are going to do in the post function. First, we get the next post. So that is the post ID we're going to assign to your new post. And then we create a new post here by inserting the new post with the new post ID and the new post, the data structure itself. And the data is just the title, the content, and the author. And the author, we don't ask we don't ask the user to pass the name of the author in this function, because in a transaction we can get the sender of the transaction. So here we assign to the address or the account of the sender from this transaction, and we store it in a variable called who. Yeah, so we create the post, insert it into the database, and then we increment the post ID and save it as the next post ID. Yeah. All right, so we have already compiled that. And now, of course, I can kill my running existing blockchain and start a new blockchain. And you can imagine the new features will be there. But in order to showcase the capability of runtime upgrade, we can do a live upgrade and add the new features here. So let's see what we get from the compilation. Of course, we get the new blockchain, so node template. If we kill the old one, run that, we will be on the new blockchain. But at the same time, if you check, there's a directory called wbuild, and within that we can get 3 WASM files, right? 3 WASM files, and the first one is the compact and compressed one. We can use this one to do an on-chain upgrade. But before we do the on-chain upgrade, we still need to take a little care about that. We need to distinguish the different versions. So where are the versions defined? It's defined in a runtime. And it's really easy, just search version in this runtime source code. And you can see now there is the spec version and the implement version. Let's increment it by 1. And we need to compile again. The original spec version was 100. And if we check there, this is, let me check where it is. So if we check the block Explorer, you can see this is the version 100. And after the runtime upgrade, we will see it increment from 100 to 101. Yeah, it's still compiling. But let me show you how to run the upgrade. So because this is the development blockchain, we have the highest privilege. So that's the pseudo privilege. You can nearly do anything you want on the blockchain. And among them, the transaction we're going to send is system set code. So we can choose the WASM file on our the WASM file we just compiled and submit it as a transaction. And after the transaction is processed by the blockchain, it will upgrade to the new version. It's still compiling. Yeah, let me create another SSH session. So yeah. And yeah, so this is the still compiling, and we can check it's actually compiling. It doesn't take all the CPU cores here. While it's compiling, we can also take a little tour of all the transactions. So within a developer extrinsics, you can see all the supported transaction types. And actually it's called extrinsics, just like transactions. So in the first job box, a drop-down box, you can see all the palettes. So in this template, there are balances managing all the balance of the accounts. And we also have pseudo. This can be used to access some dangerous places. And it has template module. So this is the module I just show in the screen. It only has do something, right? You can store some value on the blockchain. Very simple. Yeah, we can send a transaction, and the same time we also have chain state. And in this tab, you can see all the palettes here as well. And you can also check the storage in each palette. For example, now we just send a transaction to put some number on the blockchain, and if we access this variable called something, we can get just the number we submitted. Yeah, all right, it's already compiled. Let's download the WASM code and do a runtime upgrade. So it's on the target release wbuild, and here it is. Download it locally. Yeah, and let's do a runtime upgrade. We need to use sudo permission and select file where it is. So this one. Yeah, it's just around 1 kilobytes. Let's submit that. I guess it's having some problem. It shouldn't say signing for a long time. Maybe we need to refresh and start over. Sometimes there are some problems on the front end, but usually a refresh should solve most of the problems. Yeah, let's try again. Oh, need to override the weights. So the weight is just like the gas on Ethereum. It's the way to measure how large the transaction is and to limit the number of the transactions on the blockchain. But on Substrate, you can customize it a lot. So for example, if some action take a lot of resources, you can give a high weight. And here, because we store large data on the blockchain, so it syncs our weight is exhausted. So here we override it, but it's not a big issue. And the upgrade just happened. And now, as you can see, if you check the version number, it's already 101, upgraded from 100. And now we need to refresh the front end, and the upgrade should take effect. So it's still within template module, but now instead of do something, now we have the post this function. Let's post something. Hello world. And the content is hello from Alice. And yeah, so that's are the two parameters we have defined in the function, right? Let's submit the transaction. And remember, now we send the transaction from Alice, and this is the address of Alice. So it's 5G and blah, blah. Yeah. Let me just send the transaction. At the same time, I can also send another transaction from Bob, like from Bob's stash. So, hey, and this is hello from Bob, right? Yeah, so we send another post from Bob. Yeah, it's already in block. Let's check what happened. The first thing is that in the block 201, we can see the transaction is already included in the in the block, right? And of course, in the next block, another transaction from Bob is included. And now we can check the post on the blockchain. So because we have just posted 2 posts, right? So the next post should be 2. Yeah, and yes, it's correct. And then we can also check the content of the posts. If we don't, we just meet some problem. Yeah, and in theory, here we should be able to access the posts from the blockchain, but now it shows unknown. Why? Because it shows the type of the post are post, right? But the front end doesn't know what is a post. So here we need to also define what's the structure of the post on the front end. So here it is. And as you can see, it's really simple. It has title, content, author, matches the exact same definition on our raster code, right? So title, content, and author. And then we need to put the definition here. So under developer setting, developer, and we save the definition here. Yeah, all right. So after that, we can access the data stored on the blockchain. All these system level structure are already defined, so we don't have problem checking them. Yeah. So here, this is next post and posts. Yeah, and here we can see post is a map from the post ID to the post content. And here we can see the post 0, the first post is sent from Alice. And we just fill the account ID of Alice from the transaction to the author field. And of course, we can also get the address of Bob's account. And we can see these are the 2 posts from the transaction we just sent to the blockchain. Yeah. All right. So yeah. So we just finished everything to make a simple blockchain template to a simple forum post blockchain. Right. And actually, this is just the first step of the full tutorial. And if you check that, there are also step 2 and step 3. Step 2, it's like you can upgrade a single post to 2 kinds of post. One is the plain text, other is encrypted. And then we do a runtime upgrade. It can not only support to add a new type of post, it can also convert the existing post to the new data structure. So this is called on-chain upgrade. It's a little bit advanced topic in Substrate. Yeah, if you are interested, you can take a look at that. But today, I think we can wrap up a little bit. So in this workshop, we have learned the very basic concept of Substrate, and we just made a very, very simple palette to allow users to make forum posts on the blockchain. And we have touched the concept of storage items, storage value, and storage map. And we define the functions on the blockchain. And there are also something we haven't touched, like the arrow and event handling, the API and hook of blockchain. And hook is especially interesting because on Ethereum, you cannot really define something automatically triggered on some at some block. But on Substrate, you can actually define a hook. And this piece of code will run whenever a new block is produced. So you can make something automatically happen on the blockchain. And of course, the blockchain upgrade and some other blockchain related events can be handled in hooks. That's all the very advanced topics. Yeah, so what about the next step? And I think a really, really recommended website is substrate.dev, and you can check that out. So this is the developer hub. You can learn the tutorials. It have a lot of tutorials for very basic tests, right? You can create blockchain, you can define the palettes, and it can also introduce you how to write smart contract on Substrate. It also has the knowledge base. So this is the basic documentation of Substrate, and you can learn a lot of more advanced topics here. And there are also reference. So if you take a look a step deeper into Substrate, and you can find the reference manual really useful. For example, like you can search storage map here, and then you can find out what you can do with a storage map. For example, you can insert, you can get, you can even append to some the storage map. Right. So the next thing is the GitHub repo. You can find a lot of good examples from maybe unit tests or the frame. That's all are all the predefined palettes developed by Parity. So you can check how these people are writing their palettes, and maybe you can also find the Polkadot wiki very useful, because there are some concepts introduction like democracy, staking related stuff. And there's also the Element chat room. So Element, just in case you don't know that, that is the headquarters of Substrate development. So here, Element, and as you can see, there is the Substrate developer space, and the most common one is Substrate technical. You can ask questions here. And of course, if you want to join our Phala developer Telegram group, I'm really happy to answer all the questions. Yeah. So the next step, maybe you can learn about the dependencies of palettes, because you can combine different palettes together to build something more complex. And frame system, right? As I mentioned, cryptography to that can help you to build some more advanced features for your blockchain. And performance matters, so you need to understand how the different parts in your blockchain affect the performance. And the runtime upgrade, smart contract enable other developer to deploy their logic on your blockchain. And like parachain XCMP, if you're going to build a production ready blockchain, you can make it a parachain on Polkadot. And also the most low level one, the Substrate internal related things. Yeah. So that's already a long, a very lengthy workshop. And I want to use the last few minutes to talk about the Phala challenges in this hackathon. The hackathon is already started, and Phala is also one of the collaborator in this hackathon. And I think Phala is pretty unique, because we have like confidential smart contract. You can build a smart contract just like a very typical smart contract, but everything within the smart contract is confidential, because we have our own mechanism to make it secure and privacy preserving. We also have the off-chain computation, because we have a lot of workers, and all these workers are separate. They can run separate logic. So the computation happens off the blockchain, not on the blockchain. It means that we can get native CPU performance. So it's really performant compared with the other blockchains. It can also support some really interesting use cases like asynchronous HTTP request. So yes, you can send HTTP request from a confidential smart contract, just like building your own oracle, and then submit the results back to the blockchain, or submit it back to the other parachains. Yeah, just like Oracle. We also have real-time RPC. So it means that the logic, some of the logic can build in real time. You don't need to wait for the block time. For example, if you build a game, it will be very interesting because there's no latency at all. And of course, cross-chain interoperability. So we are XCM ready. So we have two challenges. One is the easy task. Another is the hard challenges. The easy task, there are two easy tasks, and the bounty for each task finished is $24. And the first is run our hello world, and the second is hack on hello world. And probably you can build maybe private notes, secret chat, or like NFT with some hidden contents. For example, you can put some image on our blockchain and it's encrypted, right? And these are the easy tasks. The hard challenge will be more complete. So for example, you can build a file encryption middleware for like hiding the assets for NFT. And you can also connect to a decentralized storage, right? And you can try to build probably a privacy enhanced DeFi to fix some problems on the DeFi area. And you can build game or password manager. And there are also some very basic stuff, very infrastructure level stuff like on-chain wallet. You can connect, maybe integrate WebAuthn, allow people to use their fingerprint to unlock the wallet like that. Yeah. But there's one caveat. We are actually under a very heavy refactoring on our code base, and I think we're going to be ready start on October the 1st. So now we're still preparing our tutorial, our hello world template, and just keep tuned in the Polkadot Encode Club Discord, and we're going to share more news gradually before the official start time. So you have an entire month to build Phala network. And yeah, we're going to prepare the tutorial, tasks, and the bounties. Yeah. All right. So that's all from my from my part. So let's see if there's any question I can just answer.
Sure, yeah, I think there's a few a bit earlier on, so I can scroll to them and read them out for you. Sure. But yeah, just to answer a quick one from Alex, who said, so we can't do the challenges before October 1st. No, the existing challenges set by Phala, you can start doing already, especially the easy challenges. But I think Hang Yin there's going to be some more challenges or something released on October 1st. Is that right?
Yes and no. There's a bit embarrassing is that today we are actually focusing on launch our mainnet mining. So it takes maybe another week before we release the full instruction to run the Hello World challenge. So okay. Yeah, we still need more time, but whenever it's ready, I will put it into the Discord group and tag everyone so people can, if you are interested, you can start hacking on that.
Yeah, fantastic. And thank you very much for the session as well. It's been a fantastic session yet again. So just going back up to the questions from near the start, we had one from Casper, which is what kind of app could be deployed on Phala? Can we have an example? Can we have, for example, a to-do app on the blockchain?
If you mean the existing app on Phala, I think the first one, I actually the first one should be the bridge, right? Actually, I think we are the first parachain to launch bridge between Ethereum to a parachain, and but it now it only supports our own token, that is Pha, from ERC20 Pha to our Phala network native token. But next step, we're going to enable the third-party integration. So it means that the other tokens can be bridged to our parachain, and then we can bridge our send this token to other blockchains. For example, like Karura, they can run the DeFi stuff, or like Moonriver, they can run their EVM smart contracts to play with these assets. So this is the first application. Now, another thing I think is pretty unique, that is mining. So I didn't mention too deep, but you can imagine our network, we have a blockchain, we have a lot of miners. This miner could be maybe 10,000s of miners, and all these miners connect to the blockchain, get rewarded. So we have the miner console. So if you're interested, you can also try to mine on our network if you have the Intel SGX support. But that's a little bit off topic. If you ask about building the applications on Phala, I think these are the recommended directions. We offer privacy, so you can build anything that cannot be achieved on Ethereum, because on Ethereum, everything is transparent, right? So maybe a very, very simple application is you can build a private notes application on our blockchain. And for example, you can save the remark of your Ethereum or other blockchain transactions on our blockchain. And this is only visible to yourself, right? And there are also some other directions, for example, hidden content, NFT, privacy, enhanced DeFi, and games, right? So these are the recommended directions.
Sorry, I was muted. Fantastic. Thank you very much. Nosferatu asked, how much slower is WASM execution compared to the native executor?
Good question. Long ago, there is a big gap, but now I think they are pretty close. In my impression, if we run the block, execute the block in native mode, it's roughly 200 blocks per second. But if we run it within the WebAssembly executor, I think it's between 100 to maybe 50 blocks per second. And thanks to Wasm time, that is the Wasm executor with JIT. I don't know how to pronounce JIT, just in time compiler. So the gap between the native and Wasm executor, I don't think is more than 100%. So I think it's really something we can ignore. But the native executor have a very large limit because you only have a single version of the runtime, right? And on Substrate blockchain, you can always upgrade the code. So a native runtime can only run within a short period, and beyond this period, you have to run the Wasm runtime. And Wasm runtime is already very stable, so it's even recommended to always use the Wasm runtime.
Awesome. Casper's asked, how are blocks stored on RocksDB? How can you read STA files there?
Good question. That's very deep. I think I don't think there's any documentation or blog post introduce you how to read the data in the database. But I do recommend you to search Sean's blog post about substrate storage. And here it is, substrate storage deep dive. And I don't think this answer exactly your question, because it's more like how the data is stored and represented in the database. And you are now asking how the database is mapping to the substrate storage. So that's actually the two parts. But this blog post is really fantastic. It comes with a video explain all the details of the substrate storage, and it's a really advanced topic. And for your the direct answer to your question, I think how to read the data stored in the RocksDB, you have to read the codes. And hopefully there are some good documentation in the code, but you cannot really find anything useful outside the code. So I think you should search in the Substrate code base.
Awesome. And do you have time for just the two last questions? I don't want to take too much of your time, Hang.
Sure.
Sure. So Till asks, can I set timed visibility for others on my private storage on Phala?
Good question. So I would like to show you something. This is on our wiki page. We do have some documentation, but it's a little bit out of date. So it's good to show you some concept, but the exact smart contract is already evolved. So that's why I'm saying we still need to wait a few days before we refresh that. So here is a confidential contract. So it's very similar to a typical contract. For example, we can define a struct called hello world. We put a counter into that, and then we can define the transaction. We call them command. And by default, everything in the smart contract is encrypted on the blockchain. So nothing is released to anyone, right? And all the transaction is also encrypted, and it only gets decrypted when it arrives to the execution runtime. And here, like we can define a command called increment. It take a value and increment the counter by the value, and that's really simple, right? But the difference comes from the query side. On Ethereum, everything is transparent. You can just download the database and get whatever you want, right? But on Phala network, everything is encrypted. So downloading the blockchain cannot reveal anything. It's encrypted. And the only way you can get the data is through query. Query is also end-to-end encrypted. And here is the tricky thing. We have an API called get count, right? And we can check the sender. We can limit, if you are a root account, then we can give you, if you are not the root account, we just reply not authorized, just an error. But if you are the root account, we reply you the real data. So it means that developing a confidential contract is really, really simple. It's really, really similar to develop just a regular backend. Everything is not transparent by default. You only define who can access which part. And only after the authorization, the data can be returned. So your direct question is it possible to limit the time? Of course, yes. You can check the block head or the current timestamp before you return anything. You can also put more complex logic to check if a request is authorized. So it's really flexible. Yeah, let me just put the link of the documentation here. If you are interested, you can take a look. All right.
Awesome. And yet the final question is from Lucamba, who asks, so my question's about Substrate and the way blocks are produced. So for every 6 seconds, there's a new block produced but contains 0 data. So when you add data, are you adding to a new block produced or the first block produced?
Let me repeat the question. I'm not sure.
Sure.
I see that. So here is the question. So every after 6 seconds, new block contains 0 data. When you add the data, are you adding to a new block produced or the first block produced? This is a really in-depth question. So just imagine if you submit a transaction on Bitcoin or Ethereum blockchain, there's no guarantee when your transaction will be included. Usually, the more gas fee you put into the transaction, the higher probability you can get your transaction included faster. But it really depends on the miners. But miners are the people on on Bitcoin and Ethereum. And on Substrate blockchain, there are no miners. There's only validator. So validator are the special nodes elected by the token holders. So that's why they call them proof of stake. And because these validators are the people who produce the block, and they have the right to pick up which transaction to be included in the next block or not. So theoretically, these validators can manipulate the order of the transaction, or they can even censor a few transactions if they don't want. But since there are a large amount of the validators, for example, on Kusama, there are more than 1,000 validators, and it's very hard to have all these validators collude and to do something harmful to the blockchain. So usually it's impossible to have the to have your transaction censored by some validator. So I think the direct answer to the question is there's no really any guarantee your blockchain will be included in the next block, but the validator will use some heuristic to determine when the transaction will be included in the block. And it depends on your gas fee, and on Substrate chain is called the tip. And I can just show you something. Like if we send a transaction, right? Blah, blah. And send a transaction. Here, there's an option called do not include the tip for the block author. By default, you give no tip to the block author. That's the validator. But you can also give some, right? You can give 100 or even more token as a tip to the block producer. That's the validators. So the more you give, the higher chance your transaction can be included faster than others, because this is basically a game theory, a very simple game theory. Yeah. So I just submitted a transaction, and as you can see, there are some tip, and in the yes, so there's no other event on Polkadot. Maybe you can see the tip goes into which validator, but on this simple blockchain, you only see the number of the tip. Yeah.
Awesome. Thank you so much, Hang, for the very detailed answers for all of the questions there, and also for the fantastic workshop. But yeah, that brings us to the end of the Substrate workshop. Don't forget, there will be another workshop on Monday at the same time, which is a ideation workshop to kind of give you ideas for what to build from the hackathon. And also, Hang is available in the Encode Club Discord in the Polkadot section. So yeah, be sure to join in if you have any more questions. I'm sure he'll be happy to answer and also tell you about all the cool stuff they've got coming in early October. But yeah, thanks everyone for coming. Have a great day or evening or afternoon, wherever you are, and see you on Monday.